This video is going to make you feel small. I want you to fight that feeling and simply appreciate the scope of the universe that you, me, and every human that has ever lived is a part of. We've been to the moon and back 9 times. And the moon is the closest celestial object to the Earth, so it couldn't have taken that long, right? Well, after the initial escape from Earth's gravitational pull, the Apollo 11 crew soared towards the moon with a velocity of 3,280 kilometers per hour. Even at that speed, it took them 3 days, 3 hours, and 49 minutes to reach the moon. That's enough time for them to circle the Earth over 6 times. Now, that might not seem that slow, but let me show you what it would actually look like. Imagine this for 3 days. And yes, we are actually moving. It takes so long because even though the moon seems close, in reality, it's 384,400 kilometers from Earth. That's as far as going from New York to Beijing and back 17 times. But what about Mars? Because Earth and the Red Planet orbit the Sun at different speeds, there are times when it is the closest planet to us, and other times when it is on the opposite side of the Sun. Even at its closest, every 2 years, Mars is about 56 million kilometers from Earth. If it were a straight shot, a spacecraft like the New Horizons probe on its way to Pluto right now, traveling 58,000 kilometers per hour, could make it there in just 39 days. But space travel is hard, and scientists have to aim where a planet is going to be, and use something called a Hohmann orbit, which uses a trajectory that is both cost and fuel efficient. Because of this, it took the Curiosity rover 253 days to reach Mars. That means, if you left for Mars on Christmas morning, you wouldn't get there until the 4th of July. So what about Pluto? I mentioned the New Horizons probe, which is the first mission to ever reach all the way out to Pluto and the rest of the Kuiper Belt, and the final mission to complete human exploration of the solar system. Reaching Pluto is a little more challenging than Mars, because its orbit is tilted and is so much larger than the other planets. At its closest point, Pluto is 4.28 billion kilometers from Earth. And at its farthest, it is 7.5 billion kilometers. Now, I don't expect those numbers to even mean anything to you. Visualizing 1 billion is tough, so I've made a separate video to help you with that as well. If you've seen the video, you can begin to imagine how incredible 1 billion is, let alone 4 or 7 billion. So, how do we expect the New Horizons probe to get there? Launched from Earth at a speed of 58,000 kilometers per hour on January 19th, 2006, it is scheduled to arrive on July 14th, 2015. 9 years later. And that is the fastest humans have ever sent a spacecraft. But if only we could travel the speed of light. That makes exploration so much easier. Then it would only take us 5 hours to get to Pluto. You know what? Let me show you. We're going the speed of light right now, towards Pluto. 5 hours of this. Alright, so for the rest of this video, let's assume we can now travel at the speed of light. That'll make things much easier, right? Now that we're out of the solar system, we might as well take a journey to the nearest star, Proxima Centauri. At the speed of light, it would still take us 4.2 years to reach it. If you've ever heard of the Voyager spacecraft, you'll know that it escaped our solar system in 2013 with a velocity of 60,000 kilometers per hour. At that speed, it'll take 80,000 years to reach the nearest star. 80,000 years ago, humans were just making special tools for fishing, far before domestication of animals and cultivation of agriculture, let alone space travel. So we are already far out of the range of our own lifetimes. But why not keep going? Let's say we wanted to travel outside of our own galaxy and experience the true vastness of space. Traveling at the speed of light, it would take 13,000 years to escape the realm of the Milky Way. That's 13,000 years of the speed. And that wouldn't even bring you far enough to be able to turn around and look at it. The entire galaxy is 100,000 light years across, so you'd have to go pretty far out for a good view. While we're out here, we might as well check on our closest neighbor, the Andromeda Galaxy. At the speed of light, it would take 2.5 million years to reach Andromeda. At the speed of light, 2.5 million years. The problem with deep space travel is that due to a mysterious force called dark energy, space is expanding everywhere at all times. Distant galaxies are moving away from us faster than local galaxies like Andromeda and Triangulum. This is hard to wrap your head around, but that's okay. It's easy to get lost in the vastness of it all. And sometimes, it's fun to do before pulling things back into our reality here on Earth. Just for a little perspective, let's take a trip through the observable universe at a speed of 5 million light years every second. Every little light you see us passing right now is a galaxy, each with billions of stars of their own, which all have the potential to have planets of their own. And there are billions of galaxies in our observable universe. From what we can see, the observable universe is 16 billion light years across. That's unimaginably large. So vast, so incredibly rich with planets, stars, black holes, galaxies, and everything in between. To the entire universe, we are just a speck of dust, a pale blue dot off in the distance. But to us, we are everything. Everyone you've ever heard of, ever spoken to, ever known and loved, has lived and will live here on Earth. For now. There's comfort to be found in the vastness of our universe. Our technology right now limits us to our own solar system, and will most likely limit us to our own galaxy sometime in the foreseeable future. And that's okay. There is plenty to explore in the Milky Way alone, and we've only just begun to do so. Billions of stars to be identified and studied, billions of planets to be observed, and daring missions to be made that will test the intelligence, creativity, and determination of the human race. We live in an exciting time, and I can't wait to see what comes next.